Welcome everyone back for the next lesson. Today we're going to start off in Blender because today we're going to start parsing object files. And one of the tools you can do to turn a 3D model into an object file is Blender. So you don't need to go get Blender for this lesson. You can actually get the object file from GitHub. So I'm just really going to tell you what's going on. So what I have here is a cube, and I added a seam on every single edge of the object file. The reason why I did a seam is so this way I can separate each face out for its own UV coordinates. So this way each face can take up the entire texture image. So once I did that, you're ready to save. So, you just go up to the menu and then you drive down through and pick to export wavefront. And then from there, you have the next screen where you can actually save your object file. Now, the important thing is for WebGL is the settings of how you output the object file. So if you see the bottom left corner, you see a bunch of settings and checkboxes and everything else. Some of the most important things you need to set is the forward is -Z, because that's the direction we go if we're moving forward in our camera. The up position is Y. Because Blender, the up position is actually Z. It's a different coordinate system in Blender, so we need to convert everything differently. So everything is up going the Y direction. And some of the settings that have checked off are very important, like apply modifiers, include edges, write normals, include UVs, definitely include UVs. Don't need to write materials, I don't think, but check it in there anyway, because I think that will just output the texture file. And objects as object, whatever. One thing I don't have checked off that you probably should check off is triangulate faces. We're going to write a parsing code that actually will take a quad and then break it down to a triangle, just in case you have an object file that's exported that way. But if you want to make your life a little bit easier, but it will make the file size a little bit bigger. But have that checked off when you export your file. So this way you can kind of just render, parse things faster because everything is just triangles. And from there you should have your file exported as an object file. So let's go back to our HTML page, and we're going to start just quickly setting everything up that we need. At the very top, we're going to load in our object-loader.js file that we're going to create in this lesson. I probably took out a bunch of things to make the page a little bit slimmed down. We'll just quickly scroll through and I'll point out to a couple of things. I know I'm not loading in the sky map images. I took that out from the previous lesson. You can leave them in there because you can then just have your stuff in here with the sky map. I just took it out just to slim things down to make it easier. Let's see, we'll scroll down some more, and we're just going to load in our new cube inside Gmodel 2, and I just commented out some of the other stuff. So there on line 54 and 55, that's our new code. We're going to use our new object loader. Scroll down some more. On render on line 86, I added in Gmodel 2. If you want, you can keep Gmodel in there, and you can see the two cubes in comparison with each other. I just changed the position for Gmodel 2. In the previous couple of lines of code. Scroll down some more. We got test shader. Test shader is slimmed down. It's bare necessities of what we need. We're going to scroll down some more. And now we got our shader and fragment, vertex and fragment shader code. Bare necessities, stuff you should be used to seeing by now. It just uses a texture instead of a solid color. And then we're going to scroll down, and we're going to actually create a new script tag. And this script tag would actually hold all our code from the object file. An object file is just a text file. So, just make the tag and put the contents of the file in here. And that's it, And so this way we're going to actually load up the object file from script. Normally in a real engine, you probably use like Ajax or something to load in the file dynamically and then parse it out. But to make things a little bit easier for us, we're just going to dump everything in a script tag and then parse it out, kind of like how we do our fragment and vertex shaders. So let's step through our object file, and so we can understand what's going on. I kind of highlighted a couple of lines, like line 5, where the line starts with v. V is for vector, so that is actually a single coordinate in the cube. So anything that starts with just the v is a vector, or yeah, it's a vertex position. So you got your x, y, and z. Then at line 13 we have vt. That's vector texture. That's actually our UV values. Easy to tell because there are only two values. There's the UV, the ST, the XY, whatever you want to call it. So VT is vector texture. Then after that, on line 17 starts VNs, and that's vector normals. So it's our normal position for all our vectors. Now the way the objects files work is they kind of compress everything in a certain way, where every unique thing is kind of its own line of code. So let's say if we have like a triangle, and we have, like, for some reason we have the triangle repeating itself going in two different normals, we'll have only one V value of it because it's a single unique position. But then we'll have two VN values because, going in one normal direction and going to a different normal direction. So and all that is tied up in this final section where line 25 is F. These are faces. And we actually get the quad or the triangle being formed in the F section. So it's each point in our face, and there's three components to it. There's the vector position, the UV, and then the normal. So that's pretty much the order. So if you look at line 25, we have 2, 1, 1. So that means the index 2, which would be line 6 in this file, that would be the vertex number 2, because the index is, unlike programming, starts at 1, where programming starts at 0. So when we are actually coding the parsing, we kind of have to keep that in mind because all our indexes start at 0, but the way the object file handles everything starts at 1. So yeah, so it would be index 2 for vertex. So it would be line 6. And then it would be index 1 of UV, which would be line 13 of the VT. And then number 1 would be the normal, so it would be line 17. So that comprises that one vertex information and its two attributes. And then it's pretty much the same thing, just rinse and repeat. And just keep, reading everything in that order. So as you're going through your faces, you have to take those indexes and reference them at the top. So that's how the object file is laid out. So now it's time to start writing some code and actually how to parse it. So create a file called objloader.js file, and this is pretty much how we're going to start off. We got 3 functions, and each one's kind of just steps through the process. At the very top, we have at line 2 DOM to mesh. This so we can just pass in our mesh name, the element ID of our script tag, that's part of the DOM, and we pass in a flip YUV. The flip YUV is to actually flip the UV of the Y position, because Blender UV coordinates works differently. Where our UV coordinate works at the top left corner of the image file, Blender does it the opposite, kind of the opposite. It's the bottom left corner. So we're going to have multiple ways of how to flip the Y coordinate. So one way would be to just change the values as we're loading them in. Another option that we did in the past was when we were loading up the actual texture image, we tell GL to flip the image on the Y position. And a third option you guys can do is that we just don't change the texture and don't change the loading data. You actually just do the conversion in your fragment shaders. So I think probably the best option would be just to load everything just in the object loader to actually handle the flipping. So that's what the flip YUV is for. So DOM to mesh creates our mesh file, and it uses parse from DOM on line 7, which just makes it an easier way to kind of just access the DOM, which then just actually uses parse object text file. I broke everything down so you can use it in different ways. Like if you're going to load from Ajax, you're going to just use parse object text and then kind of create your own mesh. You might actually have to create another function to make mesh that way. But like I said, that's why I was building everything in pieces, so you can kind of piecemeal things back together, and depending on how you load these files. So parse object text on line 9 is really the meat and potatoes of everything. So I put a lot of comments in to kind of explain each line of code to make things a lot easier. In this section, I kind of highlighted the most important things I probably need to explain between lines 18 and 24. As you see, I have like something called a cache, cvert, cnorm, cuv, and then fvert, fnorm, fuv. Now the thing is, we need to reference everything and we need to kind of rebuild everything because the object file is compressed in a certain way, like I explained before, where everything is saved as unique values, and then you use the face information to kind of link everything together. So since it's done that way, we can't really just bring the data in like normally. Everything has to be rebuilt in WebGL in our float arrays, and sometimes we need to repeat the vertices or normals or UVs for some reason, because every vertex, UV, and normal has to be unique as a group, not necessarily as individuals. That's how GL works. They have to be in groups. So, like I said before, you might have a repeat of vertex values, but each repeat of the vertex value has a unique normal or a unique UV. So that's the reason why we have two sets of arrays. We have the cvert, which would handle our cached values coming from the object file, and then we have fvert, which is the actual final vertex array that we're actually going to push into our GPU through GL. So, we load everything into the C versions, and then we rebuild everything into the F versions. And the A cache kind of just saves the unique value for I'm trying to think. It saves the unique value of the three components together. So if we're loading in and somehow we have a vertex, a UV, and a normal, the whole thing is actually repeated. Instead of saving that back into our final object, we want to reference its index in the cache file. So that's what the A cache is for. It's just in the event that we actually have a lot of repeat groups, we just reuse the index, because we're going to also build the index array for our GL on top of that. So that helps us from creating extra bits of information that we really don't need. We really want to make as little repeat of information as possible. So that's those main steps are for. All right, so in our code, we're going to loop through and kind of just parse out one line at a time. So we're going to use the new line to kind of determine where we start the parsing, from position A to position B. So, we're going to start looping at line 30, and we're going to parse our line out by, line 31. Now we're going to hit our first switch statement, which is going to check the first character of the line. And don't forget, if the first character is a V, then we know it's our vector information. If the line is an F, then it's our face. So once we hit V, we have to check what's the second character on the line. And if it's a space, it's a vertex. If it's a T, it's our UV. And if it's an N, it's a normal. So we just parse out the values of that line and just dump it into our arrays. Now we'll go into the second section, which would be our faces. Our faces are a little bit more complicated. This is now when we kind of have to link all our cache data and rebuild it into something GL friendly. So at line 57, we're going to split a line by a space. And the space would, trying to think. So this way, if we have just a triangle, we should have just three chunks of code, three sets of values. If it's a quad, we have 4 sets of values. So then by line 61, we start parsing through our indexes, the 3 or 4 set of indexes. And at line 64, we say if I equals 3 and if it's not a quad. Now here's the thing. If it is a quad, then there is an I3. Because if it's just a triangle, the I will go from 0, 1, and 2, and then it will end. The loop would end. If the loop somehow enters line into a 3, then we know we're a quad. So what we're going to do is we're going to go back 1. We're going to go to 2 and set it is a quad, because now we're going to create a second triangle. If you remember how triangles worked in the previous lessons when we were creating quads, we have 4 points, 0, 1, 2, and 3. And when we're building a triangle, the pattern is 0, 1, 2, 2, 3, 0. So that's what we're doing. So if we hit 3 and it's not a quad, but it is, we're going to go back to 2 and repeat. And we set is quad. So this one, when we come back to 3 again, we won't go back to 2. That's the reason why we set is quad, because this way we only go back to 2 once. The second time around, it won't happen. So we go to line 73, and we check if the item that we're building exists in the cache. If it exists in the cache, we just grab the index and that we saved for it and put it into our actual index file. So this way, those 3 numbers, the indexes, remember we saw like 2, 1, 1. That's what we save into our cache file, and then we save the index in our GL arrays that belongs to it. So we're going to check. Does this already exist in our cache file? And if it does, let's reuse it. If it does not, we're going to start putting it together. So inside our else, now that we have our 3 pieces of components, now we're going to have to split it by the slash, I think /. So this way 2, 1, 1 gets split. And then from there, we're going to just parse everything. Let's see, line 78, we kind of just parse our vertex data. So, we just go into our cache vertex, and we just grab the index information from it, our X and Y data from it. And then line 82, we do the exact same thing for normal. And then for 85, we do the same thing for UV. Now, UV values are kind of optional. Like sometimes they don't show up in your object file. So you might have, like in the example of 2, 1, 1, we'll have 2 blank 1. So that's why it checks to see if it's blank, it's an empty string, because it's not always going to be there. So if it's there, great. If it's not, whatever. And then we have our flip Y. And the way we flip a value, we just do 1 minus that value. So, let's say if the UV position is 0.2, we see 1 minus 0.2. Now the UV value is now 0.8. It's the inverse of it. And then once we're done parsing information, we save 211 into our cache and the index that we just created. And we just increment our index, and that's it. And let's see, if we scroll down and hit 103, we kind of just, if we're on 3 and it is a quad, we kind of just finish up the triangle. That's about it. And then the function just continues on, and all we do is just add in our, we're moving our position that we're parsing by 1. And then we're just getting our new position B to get the next line of code. And then the loop just repeats itself. It's overall, the function is actually not that large. It's very large because I have tons of comments, but it's very simple. Hopefully I managed to explain what's going on in this function. So that's pretty much it. And when we're all done, we just pass in all our arrays that actually build this model, like that we've done normally in the past. Now, if you go back to our browser, you should just see our cube. That's it. We rebuilt the cube from our object file, so there's nothing special about it. if you see what we see, then you're great. You're done. Your parser works beautifully. If you got it from GitHub, it should work perfectly. So there you go. Now you have your cube. But you know what? Cubes aren't fun. So a long time ago when I was building this, I went to I think it was called Blender Swaps, and I found a pretty good free low poly model of a pirate girl, and it looked really cool. And I wanted that as the first thing that I always wanted to make, kind of like Sketchfab's kind of viewer. That's what kind of I wanted to do as just an experiment to see if I can learn WebGL. So we're kind of finally at this point. We finally reached our first milestone that I really wanted to get with the series, is really just loading in an actual model. So if you get that Blender file, then you can just export it as an object file, and you should be able to load it in just fine, just the way we did it with the cube. The cube is a simple thing. So just rinse and repeat the process. So if you rinse and repeat the process, you will then get this. And ta-da! We have our model that I had in the introduction. So this is the pirate girl. I will put links to it in the description. And if you go to GitHub, you will get the pirate girl as an object file already set, ready to go for loading. And we kind of do the same thing. We just take text files and we just dump it into that script tag in our HTML page, and it will render just fine. And all you gotta do is put in the right trying to think. I put in the right texture file for her. So I'll have all in the description, and a lot of it will be in GitHub, so you can kind of just get to it really. So, but here we are. Screw cubes. Now we actually got models with textures. And if you want to go back, and if you didn't remove all the sky map stuff from the previous lessons, you'll have this. You got your 3D model in a sky map rendered world. So, in 11 lessons, we went from just rendering little dots to actually having a world and a character in it standing on this weird grid platform in middle of space. So there you go. We finally reached the really good point in it. And this is really as far as I was kind of thought of going, but I'm having so much fun with this and learning so much. Like sky maps was something that was never planned for, that I'm probably going to keep going. I've already start prototyping terrain. So that's probably one of the next couple of things that I'm going to handle that. It's using triangle strips to create terrain. So we can have terrain, we can have sky maps, and we can have her. So we can start having a world, actually start building something. Originally I just wanted to make like kind of like a very simple bare bones Sketchfabs type of viewer, but maybe now we're going to maybe make this into a game engine, a web-based lightweight game engine. Maybe I should just call it the lightweight GL. I don't know, game library. I don't know. I have no clue. Like I said, all this is unplanned. I'm just really having fun with this. Hopefully you guys are enjoying the ride with me as I learned and do this stuff. So yeah, hope this is great. I hope you're having fun. I hope you love and excited the fact that you're actually loading up a real model file. Experiment. Go to Blend Swaps and find other models and see if you can save them as object files and then load them in. Low polys are easier because they have less textures to deal with. So if you have like one model that has just one texture file, it'll be easier for you to load right now because we don't have like parenting set up. So we can have we load up multiple objects and then have separate textures. We're not ready for that yet. But if you have a single simple model and a single texture, you can definitely do it now. That's for sure. A couple of things I'm kind of thinking about exploring. After I'm done doing terrains, I want to do maybe WebVR. I think that'd be really fun to try out. I've seen some good YouTube videos of it actually kind of working, especially with Vive. I have a Vive and they have game controllers. So the guy who added that functionality into Chrome, hopefully it's finalized, and I would love to experiment with that. So that might be something we're going to do. We're going to take our little graphics engine and see if we can apply WebVR to it. If you don't have WebVR, maybe it's something you guys can skip. But it's something I want to do. It's something just quick. I just want to be able to see if we can get our stuff rendering on a headset, maybe even use the Vive controllers for something. After that, I want to explore maybe voxels. Voxels seems to like to be a very fun thing to do. Maybe it'll be our next milestone. You know, it's the stuff kind of like from WebGL. So, not WebGL, I'm sorry. It's stuff for like Minecraft. Minecraft is kind of a voxel kind of environment, you know, build a terrain. Maybe you can, you know, maybe I'll make like a voxel editor where you can have just our chunk, and then you can kind of use the mouse to kind of create cubes in different spots. You can kind of create like a voxel model type of thing. So voxels definitely. I would like to do more things with maybe build a spline thing. Kind of like in Unity, you can have a spline. It's kind of like a curved line that you can kind of just edit. Definitely have to deal with mouse controls at some point, you know. So this way you can kind of select an object on the scene and maybe move it around. That's something else to explore. We definitely have to deal lighting. I think between this lesson and the terrain, I have to do like something about lighting, because lighting is very important in the prototyping of terrain I've been dealing with. So yeah, there's a lot of things I want to do, and every couple of days I have another idea. So it's trying to figure out the time to learn it, to, you know, have a good understanding of it, and then find a way to kind of explain it to you as we progress through the series, and putting things in the right order so we can build off from the previous lesson, kind of like how we've been doing in this series. Oh boy, I've been talking for way too much, so let's end the lesson now, and see you guys next time. Bye-bye.